Hey gang, so we're going to look at average velocity and instantaneous velocity. Those of you that remember your physics, I actually don't know if you do this in physics, but maybe you do. So we'll see. Average velocity. So we're going to do how far you've gone. This is average velocity. How far? Oh my gosh, y'all, the bottom just fell out, meaning it's raining cats and dogs. How far you have gone over how long it took you to get there. How long it took you to get there. Time, right? Displacement. Over time. Oh, move that over a little bit. So, I'm sure most of you remember that. You've all had physics, or you're all in physics right now, and you're probably working on that. Isn't displacement over time kind of the same thing as slope? F of t plus h, and we'll call that t naught, minus f of t naught, all over h. And if you think about this one right here, this f gives you the position after just a little while. How far did you go? So let's write f gives you position after a little while. And F naught, that's the position where you're starting from, right? This is where you started. I'll say, well, I probably should have said starting position, but I'm going to say position at start, because I already started writing that. And H is our time. Time traveled. Recognize that equation? I hope so, because we've been doing it the last couple of days. All right, so here we go. Find the average velocity of s of t equals 1 plus 3t minus 2t squared on an interval of 1 to 2. Kind of let you think about it for a minute. Okay. So let's take a look at this. Let's talk about the starting time. What is the starting time? Well, I'm starting at time 1, and I'm traveling to time 3. So my starting time is 1. What is h? How much time has elapsed during this? Hopefully you're not thinking, well, 3 seconds, because it's from 1 to 3. No, how much time elapsed? Let's actually write that. Elapsed time. How much time went by? We went from 1 to 3, right? So I'm going to do 3 minus 1, which is 2. Only 2 seconds, it doesn't say. We're going to assume it's seconds. Only 2 seconds have gone by. So if I follow my formula here, let's do velocity average, the average velocity. It's going to be, and we're going to use an S. Normally we did F's, but this is an S. So I'm going to see S of t plus a little bit minus s of t from the starting divided by how long we did it. Pretty sure you can see where we're going with this. How long did we go here? This would be s of how much time elapsed? 2, right? So we're going to do t naught, which is 1, plus h, time elapsed was 2, minus s of t naught, we started at 1, divided by h. H was 2. All right, so that means the average velocity is nothing more than s of the end, which was 3, minus s of where we started, all divided by the 2 seconds or minutes, whatever it was that we actually did. Now, You may be thinking, Mrs. Dean, why? I can see this, but I don't understand what you did right here. That's okay, as long as you can understand what I'm doing here. I just wanted to show you how I got from here, down to there. Doing the same math we've been doing this whole time. All right, let's come over here. I'm just going to do these real quick. S of 3 would be, plug 3 into this equation. 1 plus 3 times 3 minus 2 times 3 squared. 1 plus 9 minus, let's see, that's 9 times 2 is 18. 10 minus 8 would be negative 8. So velocity average would be negative 8 minus, and then let's do S of 1. So that would be 1 plus 3 times 1 minus 2 times 1 squared, which is 1 plus 3 minus 2, which is 4 minus 2, which is 2. All divided by 2. I'm just going to go ahead and put in equals here. Negative 8 and negative 2 is negative 10 over 2, which is negative 5. So that means the average velocity is nothing more than negative 5. All right, average velocity is just the slope. We just have to figure out from the time we stopped to the time we started and divided by how much time's elapsed. It's pretty easy to do that velocity on that. But let's take a look now at, if I can find it on here. Keep going. There it is. Instantaneous velocity. How much time passes in an instant? Like when you think about it, like how much time? How much time do you think passes in an instant? It's got to be at least a little bit of time, right? Because if it didn't, we'd all be the same age like for forever because time would never pass. So some little bit of time has to pass. So as you think about that, if just a little bitty bit, like it's just like a fraction of a split of a second, you might be thinking, oh, she's going to do that limit again, isn't she? And you would be absolutely right. Oh, and there's my daughter calling. Okay, I'm going to pick up with instantaneous velocity next. Okay, so back to instantaneous velocity. So I just said that, velocity can't be, like if you're doing instantaneous, there has to be a little bit of time pass. But, because if it didn't pass, then we'd be like the same age for forever. So you want to think about this as a limit. As h approaches 0. Now, how is that different from what we just did? We just found the average velocity. We just plugged in the values and found it, right? Average velocity and average over time. But instantaneous velocity is going to be a limit. It's going to be at that split second in time, bam, what happens? What's going on? So it's going to be a limit. So velocity instantaneous is going to be the limit as h approaches 0 of f of t naught plus h minus f of t naught all over h. Recognize that formula? Oh yeah, that's the limit and the slope. So the limit as we approach that value in this situation as we approach 0. So on this first one, S of t equals 500 minus 16t squared. Find the instantaneous velocity at 5 seconds. So for whatever's going on, something's fallen down, maybe off of a building or something, and bam, at 5 seconds, exactly at 5 seconds, how fast is it going? Isn't that kind of like the slope at a curve on a point? Yeah, it kind of is. Okay, so here we go. Our function is 500 minus 16t squared. That's what we're starting with. All right, so we need to know at time 5 seconds, right? At t equals 5. So t naught is going to equal 5. We need to find, if it's at 5, what's that value? So let's find S of 5. What happens at 5? That's 500 minus 16 times 5 squared. If I were to plug that into my calculator, I worked this earlier, and what I got, and I'm hoping it's the same as what you got, is 100. So that means I've got 5, 100. And that is T naught and F of T naught. You know what? I'm kind of messing myself up. I did lowercase t's and capital T's. Since I did lowercase and I can fix it, I'm going to make these lowercase just so everything matches up. I'm going to get everybody confused if I don't. If I start using different letters everywhere. Okay, so I'm going to highlight this. Here's that one, right? We're good with that one. Now we need to do a little bit beyond T, a little bit beyond 5, right? So I'm trying to see how much room I'm going to need. Oh, I'm running out of room. So we need to do S of T naught plus a little bit. Well, that's going to be, y'all are probably already regretting this, 500 minus 16 times, yeah, that right there. T naught is 5, right? Plus a little bit squared. And we're going to do some of this off to the side because some of it's going to get kind of messy. So here we go. So let's come over here and we're going to do the limit. I'm still in the screen. As h approaches 0, f of t naught plus h. That's this right here. That's this times this. Now, this times this, we're going to plug it in, but then we're going to do a little bit of algebra off to the side. Minus 16 times 5. Oh, sorry. I got a little carried away. Oh, no, well, I can do that. That's still good. We're still good. Plus h squared. That is this right here. Is this right here, which is this right here. Now I need minus f of t. Minus, well, remember my f of t naught was 100. All over. Oh, what was h? I don't know. I don't know what the h is. Remember over here, instantaneous, I don't have a time. It's like a split second, like, boom. It's as we approach h. So we're going to have to put that right there. So we need to simplify this, and it's going to be a little bit messy. I am going to go ahead and write it out just algebraically so you have it. 500 minus 100, I'm going to go ahead and do that. 500 minus 100 is 400, so that's 400. Minus 16 times 5 plus h times 5 plus h. All over h. And remember, the goal is to factor this out so that the h's cancel. Right now, nothing's canceling. So I'm going to do the limit as h approaches 0. I'm going to multiply this right here. Here's what I'm going to do. I'm going to actually kind of cheat a little bit. 5 times 5 is 25. 5 times h will be plus 5h. H times 5 will be plus 5h. H times h will be plus h squared. So I'm going to kind of write that there so I can kind of write it down here. That's 400. 5h and 5h give me 10h. So I'm going to keep that in the back of my mind. 16. I wonder if I should. I think you'll be okay if I do all this in one step. Negative 16 times 25. Negative 16 times 25. So 16 times 25, that's going to be minus 400. Look at that. Those are going to cancel out. Negative 16 times 10. Because 5 plus 5 is 10. 10 times 16 will be negative 160, and we still have that h. Negative 16 times h squared will be negative 16 h squared all over h. This is just algebra here, so know that if you're a little bit lost here, this is just algebra review. 400 minus 400, bam, gone. Okay, what I'm going to do on this next line, I'm going to factor out that h, because it's all about canceling the h. 16 and 16, or 100, I know I could factor out a 16, but there's no need to. I'm just going to take the h out of the top. And when I do, I have negative 160 minus h left. Oh, 16, sorry. Minus 16h. All over that h right there. All right, lo and behold, h and h cancel. So the limit as h approaches 0 of negative 60 minus 16h would be negative 160 minus 16 times, plug in that 0, which is negative 160. Instantaneous velocity at 5 seconds would be negative 60. So let's do velocity instantaneous at 5 would be negative 160. You probably know where this is going, right? That was at 5 seconds. What if I wanted the instantaneous velocity for any second? Yeah. What if I didn't want to do specifically to 5? What if I wanted to know at any time? Well, we can do it. So same problem repeated, but instead of doing it at 5, we're going to do it for any second. Now, it does take a little bit of work, but we can do it. So here we go. So we're going to do s of t. I'm going to do all lowercase t's. Is 500 minus 16t squared, right? Okay, let's do s of t naught plus h. So that means I'm going to plug this in for the t. So that's 500 minus 16 times t naught plus h squared. Because I know we're going to have to simplify that, I want to go ahead right here while I have room, and I want to go ahead and simplify that. So that's 500 minus 16 times. Now remember, this is going to be t naught plus h times t naught plus h. So that's 500 minus 16 times t naught squared, t times t. T times h would be plus t naught h. T times h would be plus t naught h. H times h would be h squared. Now, I'm going to do two things on this next one. I'm going to multiply by negative 16, and I'm going to add terms together in the middle. That'll be negative 16 t naught squared. This t naught and t, that's going to give me 2t, and 2 times negative 16 will be negative 32 t naught h. And then negative 16 h squared. Okay, this one right here, this is s of t plus h. I need to know that because I'm going to have to do the limit. So I'm going to have to do the limit as h approaches 0 of s of t plus h minus s of t all over h. That's what I need to do. I don't know what specific time it's at, so I don't have any way of simplifying anything. So the limit as h approaches 0. This one, which is all of that. And yes, it is messy. 500 minus 16t squared minus 32t h minus 16 h squared minus this whole thing. Be super careful. You got to remember to put parentheses around this. Okay, I'm noticing myself forgetting some of my knots. All over h. Now, where mistakes will happen is when you write stuff down on the next line. I'm going to do, I'm trying to decide, you know what, I'm just going to go ahead and write it. I'm going to write this out again without parentheses. So 500 minus 16 t naught squared minus 32 t naught h minus 16 h squared minus 500 plus 16 t naught squared all over h. All right, we are going to simplify this. All right, 500 and 500 are gone. Positive 16 t naught squared, negative 16 t naught squared. I said those backwards, but anyway. Negative 32, none of the others are going to go out. So here's what we have. Negative 32 t naught h minus 16 h squared all over h. So remember, the goal is to try and get rid of some of the h's. I'm going to go ahead and factor this as h approaches 0. H and h, so I can pull an h out. That's negative 32 t naught minus 16. H squared is going to be h all over an h. And lo and behold, the h's cancel out, and I have the limit as h approaches 0 of negative 32 t naught minus 16 h. That's all that's left. I can take it and set it equal to 0, or substitute in the 0, negative 32 t naught minus 16 times 0. So the instantaneous velocity, velocity instantaneous, at any second, whatever second I want it to be at, this goes to 0, so that's negative 32 times t naught. Bum, bum, bum. Okay, let's check it. Does that really work? Like, are we sure about that? Well, remember we had that time earlier. We had what's the instantaneous velocity at 5? Let's see. Velocity instantaneous would be negative 32 times t naught, which in this case was 5. Oh, wow. Negative 32 times 5 is negative 160. So check, that did work. Instantaneous velocity is nothing more than the limit as x approaches 0 of the slope. All right, let's see where we're at. All right, so this is page 10 that we are on, and I'm going to go ahead and keep, actually I'm going to stop, I'm going to stop my video here. I'm going to try and piece those together.